Okay, now let's take a look at example 1 of area 7, which is isolating variables. Generally, these are pretty straightforward problems. All you're supposed to do is to set the equation such that the variable of interest, in this case, uh, R1, is sitting on one side of the equal sign, and then the other variables are sitting on the opposite side of the equal sign. So here we have this scenario here. We are given this expression and we want to express this in terms of R1. All right. Now, since we want to express this in terms of R1, the first thing to do is to rewrite this equation such that R1 is sitting on y side in any form as it is. So here I'm going to move, in this case, I'll say, look, if I want R1 to sit on its own side, then I'll say uh, R1 will be equal to, let's put R1 will be equal to 1 over R minus 1 over R2, right? So I move R2 to the other side. Now, as you can tell, if I can manage to simplify this, then whatever I get, if I flip it, take the reciprocal of this, that will give me my R1. So let's play with that here. So here, the best thing to do is I'm going to take the LCM here, which will be nothing but R and then R2. And then R gets into this one, obviously, is R2 minus R2 comes into this one, just R. And therefore, I can say that 1 over R1 is equal to this. Now, like I was saying, if I flip this, take the reciprocal on both sides. So taking the reciprocal on this side becomes R1 over 1. And that will be equal to R times R2 divided by R2 minus R. And R1 over R is 1 is R1. And therefore, this apparently is the formula that governs R1, R2, and then R. So go back to the answer. You see it's R2 times R, R2 minus 1. Obviously, this here is your answer. So this is how you isolate variables. Very common practice. It's a very easy problem to handle. All you got to do is to put the variable of interest on one side. You can decide to put it on the right side or you can put it on the left side of the equal sign. So that should be a straightforward solution.